All right, welcome to The Explainer. Today we're diving into something really cool in the world of AI. It's a new way of thinking about how AI learns, one that could finally help them stop being just simple instruction followers and start, actually improving on their own. We're talking about learning from mistakes in real time, just like we do.
Researchers have this brilliant way of describing a huge problem with today's AI agents. They call them clever but clueless interns. And it's a perfect description, right? They can follow a super complex set of instructions to the letter, but there's always a catch. The second they hit a roadblock or make a mistake, they're stuck. They can't just sit back, think about what went wrong, and then come up with a new plan. And that inability to learn on the fly is a massive barrier. It's what's holding them back from being truly useful in the real world, where things are messy and never go exactly as planned. So that brings up a really big question. How do you even test for this? How can you tell if an AI is actually getting better at a task in real time? Well, you need a really tough standardized test, something that can push them to their limits and measure exactly that. And that's where the JTTL benchmark comes in. To really put AIs to the test, researchers turn to something kind of old school, text-based adventure games. Now, we're not talking about simple stuff here. These are complex puzzles that demand serious planning and a real understanding of story and context. Basically, they're the perfect virtual bootcamp for this kind of learning. The process itself sounds simple, but it is absolutely brutal. Here's how it works. The AI plays a full game. It messes up. And then, boom, the game resets to the exact same starting point. The only thing the AI has to go on is its memory of what it just did, and it has to do this over and over and over again, hopefully getting a little bit better each time. So, when they put existing AIs through this ringer, well, the results were pretty clear. Current methods just aren't cut out for this. Things like reflection or using memory gave them a tiny boost, but they didn't really change the agent's core thinking. And the usual go-to, reinforcement learning, it's just way too slow and clumsy for the kind of fast-paced learning this test requires. Okay, so to crack this nut, researchers came up with a totally different idea. A really radical one, actually. They thought, what if we stop trying to teach the AI in the traditional sense, and instead we let it evolve? And that's what brings us to EvoTest. This is the new framework, and its secret sauce is literally evolution. Forget about all that complex, super technical fine-tuning. The idea here is much more direct. After every single game, the entire agent gets an upgrade. It evolves into a better version of itself for the next run. So how does it work? Well, it uses this really clever two-agent system. The best way to think about it is like a player and a coach. You've got the actor agent, that's your player, the one actually in the game making the moves. Then, once the game's over, the evolver agent, the coach, steps in. The coach reads the entire game transcript, like watching the game tape, and figures out a better strategy for the next round. So, when we say it evolves the entire agent, what does that actually mean? We're not talking about just tweaking one little thing. We're talking about a complete overhaul of its entire game plan. The coach basically goes in and rewrites the player's digital DNA. It targets 4 key areas of its programming. This is a total top-to-bottom evolution of the whole system, which is way more than any other method even tries to do. First up, the policy prompt. This is basically the agent's high-level playbook. The coach rewrites it completely. For parts of the game the agent solved, it adds a literal step-by-step walkthrough. And for all the traps it fell into, it adds big, bold warnings, a what not to do list, to make sure it doesn't make the same dumb mistake twice. Second, it builds a memory. But this isn't just a vague recollection, it's a structured database. Every single time the agent does something that increases its score, that exact sequence of moves gets logged. It's like building a personalized cheat sheet that the agent can pull up whenever it gets into a similar spot. Third, and this is really cool, it actually tunes the agent's personality. Think of it like adjusting knobs on a control panel. If the agent was just doing the same thing over and over, stuck in a loop, the coach might crank up the creativity knob, the temperature, to get it to try new things. If it was being too chaotic, it might dial it back to make it more focused and deliberate. And finally, number 4, it sharpens the agent's internal logic. It actually evolves the rules for how and when the agent uses its own memory and tools. So over time, the agent doesn't just have good memories, it gets smarter and more disciplined about when to actually use them. Okay, so that's the theory. But here's the billion-dollar question, right? Does it actually work? Does all this rewriting of digital DNA
actually make the AI better at the game? Well, the results are honestly pretty dramatic. When you look at the learning curves, you see other methods just completely flatline. They barely improve at all. But EvoTest, it's this beautiful, steady upward climb, going from total failure to actually mastering the game. It's not just playing, it's learning. And it's learning efficiently with every single try. And if you want a hard number, how about this? EvoTest showed a massive 57% performance boost over traditional reinforcement learning. And remember, that's the method that's supposed to be the gold standard for this kind of problem. A 57% improvement is just huge. And it wasn't a fluke. I mean, look at the data. Across the entire benchmark, EvoTest just blows the competition out of the water. Its average score was way higher than any of the other approaches they tested. We're talking reflection, memory, you name it. It wasn't even close. All right, so why does any of this matter? I mean, who cares if an AI can get good at some old text adventure game, right? Well, this is about so much more than that. What we're seeing here is a huge shift in how AI can learn. See, most AIs learn from just a single number at the end, a score. It's not a lot to go on. But EvoTest, it learns from the entire story of its experience. It analyzes the whole narrative, which means it can figure out exactly what actions led to success or failure. This allows for much smarter, more surgical changes to its strategy. So what you should really take away from this is that EvoTest isn't just a cool experiment. It's a foundational step, a blueprint for creating agents that can truly adapt and self-improve out in the real world. This is how we get from those clueless interns to having AI that are actually invaluable, adaptable experts. This work really pushes us one giant step closer to that future. It suggests that maybe the key to unlocking truly autonomous AI isn't just about learning in the way we've always thought about it. Maybe it's also about evolution. And that leaves us with a pretty fascinating question to chew on, doesn't it?